Hello, I welcome you all to this another interesting screencast. We're going to be solving this engineering mechanics problem, and it reads that the dragster starts from rest and has the velocity described by the graph. Construct the position time graph during the time interval 0 to 15 seconds, also determine the total distance traveled during the time interval. Right, solution. So we have this dragster here, and we've been shown that its velocity from time equal to 0. Okay, 0, and the velocity increases linearly, right? Velocity from 0 to 5 is 30t, and then from 5 seconds the velocity begins to decrease linearly, okay, with a slope of about minus 15, and then when it hits 15 seconds, it comes to rest. Right, so I've been asked to find the position time graph. We know that velocity is equal to instantaneous velocity is equal to ds dt, and therefore our ds is going to be equal to v dt, right? Okay, so we have two intervals. We have t from 0 to 5, and in this interval our velocity is equal to 30t. All right. Okay, and then the boundary condition at time equal to 0, v naught is also equal to 0. Therefore, integrating this from 0, okay, to s, okay, because our displacement also will be equal to 0, is equal to integrating from 0 to t. V will replace it by from here to there, from there to there, okay, which is 30t and dt. We did an integration here. We find that we'll have s equal to 30t squared over 2, which is equal to 15t squared. This is the quadratic. So let's work out the t, I mean the position in interval 5 to 15. So from 5 to 15, we have the velocity equal to minus 15t plus 2 to 5. All right, and the conditions, initial conditions at t equal to 5, because we're dealing with 5 there, v naught will be equal to 30t, okay, 30t, and our t is 5, so this is 30 by 5, which will give us 150, right? 150 meters per second. Okay, and then our s naught at this point is going to be equal to, so we are using this equation, is going to be equal to 15t squared, and this is going to be equal to 15 times 5 squared. This is equal to 15 by 5 squared. What do we get? We get a 375. So with this information, we can go ahead and bring the integration. So we are starting from 375 to s. This is s. 375 to s is equal to, what is our v here? Our v is minus 115t plus 225, okay, dt, and we are integrating from v0, we found it to be 115, and then to v. Okay, so here is going to be equal to s minus 375. We did the integration this side, is equal to this side also, it will be minus 15t squared over 2 plus 225t, Okay, 150 there and this. So here it will give us s minus 375 is equal to negative 7.5 t squared plus sorry, this is time. It is from 150 to the time. What time here? This is the time. Sorry, this is the time here. Sorry about that. So the time is from 5 seconds. Okay, 5 seconds to what? 5 seconds to t. Okay, we're integrating with respect to t. So this is 5 to t, like so. Sorry about that. So minus 7.5 t squared plus 225 t, then minus, this is a 5 down, minus it becomes a plus 7.5 by 5 squared, and then minus 225 by 5. Okay, can I just write the information here so that I wrap? So from 0 to 5, found that our v, our s, which is position, is equal to 15t squared. And then from 5 to 15, we found that our s, this is what we are finding down. Can I just wrap this information here? Okay, so therefore our s is going to be equal to negative 7.5 t squared plus 225 t plus 7.5 by 5 squared minus 225 by 5, and then I removed this value, I took it to the other side, it becomes a plus 375, right? Then we have s is equal to, grab the calculator, we have a 7.5 by 5 squared minus 225 by 5 and plus 375. So we have 7.5 by 5 squared minus 225 by 5 plus 375. So this gives me a minus 7.5 t squared plus 225 t, and then a minus 56562.5. This is a quadratic, right? Okay, so I want to check this at t is equal to 5 seconds. I'm supposed to find, if I used this s of 15t squared equal to 15 by 5 squared, what are we getting? If we use this, we're getting a 375. So using this equation also, I'm supposed to find this at t is equal to 5 seconds because there's a continuation. So s is equal to minus 7.5 t squared, which is 5, plus 225 by 5 minus 562.5. What does this one give us? So minus 7.5 by 5 squared plus 225 by 5 minus 562.5. So I'm finding the same 375, so it means our quadratic expression is fine. So we can place it there. So we have a minus 7.5 t squared plus 225 t and minus 562.5. All right. So with this information, I guess we can move on. All right. We can begin the plotting, right? Okay. We can begin the plotting. We are only plotting, also determining the total distance traveled. Okay, we are also determining the distance traveled, right? All right. Okay. Okay, it's fine. So we know that. Let's work out the distance. The distance before we start plotting distance travel. Okay. So from 0 to 5 interval, we are going to be using from 0 to 5. We'll be using s is equal to 15 t squared. Okay. So we are saying if this is our number line, this is 0. So now we'll come and draw this later on. First, let's do the calculations. So we are saying s at s is equal to 0, we have 0, and at s is equal to 5, we have 15 by 5 squared, and this is giving us 375. So from 0, the dragster moves 375 to the right of 0. Okay. And then in this interval from 5 to 15, 5 to 15, we have this position function negative 7.5 t squared plus 225 t minus 562.5. So we know that s of 5, okay, minus 7.5 by 5 squared plus 225 by 5 minus 562.5 gives us a 375. We did this, right? Remember, we did this and it gave us that value 375. So, and then s of 15, let's see how far this minus 7.5 by 15 squared plus 225 by 15 minus 562 by 5. Let's see what we get. So minus 7.5 by 15 squared plus 225 by 15, 225 by 15, then minus 562.5. So this gives us a 11125 meters. Is that so? Okay. So a minus 7.5 times 15 squared plus 225 by 15 minus 562.5. Okay. So 1125. Let's see, times 15 this. Okay, that's 1 unit. So it gives us 11 by 5, 15 squared plus 225 by 15, and then minus 562.5. So 1125. All right. So if we are to draw this, on the number line to see how this dragster moves. So from 0, when s is equal to when time is equal to 0, s is 0, it will move here. Okay, and then when s is equal to 5, the particle will move up to there, which is 375. And then at t is equal to 5, so here t is equal to 0. Then at this point t is equal to 5. So we shift the equation at t is equal to 5. We use this other, because the velocity here, you've seen it is changing. Initially it was increasing, and it begins to it changed direction, right? So from here, when t is equal to 5 for this equation, it gives us the same. And then when t is equal to 15, we see it further moving up to the distance of about 1125. Okay, so there is no back and forth movement, right? So therefore it means the total distance traveled is equal to 1125. Okay, because they are all being measured from 0. So total distance traveled 1125. And then if I was to plot a displacement time graph, we're going to have something like this. We have s in meters, we have t in seconds, and we have the quadratic there. Okay, let me say we have 5 here. We have 5, and then let's say 15 seconds. So we have a quadratic there that opens up like so. Okay, something like this. Okay, and then in this interval we have another quadratic, but it opens in the opposite direction. All right, so we have this point here, then it goes something like this. Okay, all right. Right, so this point here we said is equal to, this point here is equal to 375, and this point here, which is the maxima for this particular quadratic equation, where velocity is equal to 0, is s of 15. We found it to be equal to 1125 meters. Okay, so I guess this is about it really. I hope the video was helpful. Please continue liking and subscribing to my channel. Bye.